All right, so we're about to start chapter 4.5, which is solving rational equations and solving literal equations. So I'm going to do the solving rational equations part first. And remember that a rational equation contains one or more fractional terms. To solve, step one, find the LCD. Step two, multiply the numerator of each term by the LCD. Step three, solve the equation. And step four would be to check that none of the solutions result in a zero denominator in the original equation. So we're going to start by doing a few examples here. Example. If we have to solve negative 9 over x is equal to negative 5 over 3x plus 1. First, notice that the LCD based on x and 3x, the LCD is equal to 3x. And notice that x cannot equal to 0 because that would mean dividing by 0, and we can't divide by 0. So we're going to go ahead and follow the process here. 9 over x equal to negative 5 over 3x plus 1. And then we're going to multiply each term by 3x. And now we can see that we're able to cancel 3x here, cancel the x here. And that leaves us with negative 9 times 3, which is negative 27. Negative 5 times 1, which is negative 5. And 1 times 3x is 3x. Add 5 to both sides. That gives negative 22 is equal to 3x. And then finally divide both sides by 3 to give x is equal to negative 22 over 3. We check to see this answer is not equal to 0, so this is a great answer. Example, 10 over x minus 7 over 10 equal to negative 1 over x. So LCD is equal to 10x, and again, x cannot equal to 0. So we're going to follow the process here and multiply everything by 10x. Cancel the x's here, cancel the 10s here, and cancel the x's here. That leaves us with 10 by 10, which is 100, negative 7 by x, which is negative 7x, and 10 times negative 1, which is negative 10. Take away 100 from both sides to give negative 7x is equal to negative 110. And then divide both sides by negative 7. So x is equal to, a negative cancels out with negative to give positive 110 over 7. That cannot be reduced, so our answer is done right there. Example, we have 1 over x minus 9 minus 6 is equal to 6 over x minus 9. So the LCD in this case is x minus 9. And notice that x cannot equal to 9. Because if we substitute back 9 into this original equation, we would be dividing by 0, and we're not allowed to divide by 0. So everything gets multiplied by x minus 9. Then we go ahead and cancel. So we've got 1 times 1 here. Distribute right here. So negative 6 times x is negative 6x. And negative 6 times negative 9 is positive 54, is equal to 6. Collect like terms. We have negative 6x plus 55 is equal to 6. Then we go ahead and take away 55 from both sides to give negative 6x is equal to negative 49, and divide both sides by negative 6. X is equal to 49 over 6. Again, cannot be reduced, so we leave that as it is. One more example. 2 over x, x minus 1 is equal to 2x plus 1 over x plus 3. So the LCD now is the product of the denominators, which is x minus 1, x plus 3. And x cannot equal to 1 or negative 3, because those terms would make the denominator 0. So everything gets multiplied by this LCD that we establish. Everything gets multiplied by this. 2x into x minus 1 x minus 1, x plus 3 equals to 2x plus 1, x plus 3, x minus 1, x plus 3. X minus 1 cancels out, x plus 3 cancels out. So we're left here with 2x into x plus 3 equals to 2x plus 1 into x minus 1. So we're going to go ahead and distribute and collect like terms. We've got 2x times x is 2x squared. 2x times 3 is 6x. Now we have to FOIL this out. So first outside, inside last. X times 2x is 2x squared. That's first. Outside is negative 2x. Inside is x. And last is 1 times negative 1, which is negative 1. Notice immediately that the 2x's cancel out. And we're left with 6x is equal to negative x minus 1. Add x to both sides to give 7x is equal to negative 1. And then divide both sides by 7 to give x is equal to negative 1 over 7. Continuing, we want to do a few more examples. So let's look at this one. We've got 6 over x minus 3 plus 2 over x minus 3 equals to 2 plus 8 over x minus 3. So notice that x cannot equal to 3. All right, let's go ahead and go and follow the process here. We're going to multiply everything by x minus 3 to clear the denominators. Remember to multiply every single term by x minus 3. So everything has been multiplied by x minus 3, and then we cancel. This leaves us with 6 times 1 plus 2 is equal to 2x minus 6 plus 8. We distributed this expression here to give 2x minus 8. Collect like terms. We have 8 is equal to 2x plus 2. Take away 2 from both sides. It gives us 6 is equal to 2x. Divide by 2. X is equal to 3. Now, go back to what we have at the start. We cannot have x equal to 3 because that would result in dividing by 0. So there is no solution here. Does not exist. We have to get rid of this answer because 3 cannot be one of the solutions to this problem. Here's an example. 4x plus 20 over x equals to 24. So everything gets multiplied by x to clear the denominator. 4 times x plus 20 over x times x equal to 24 times x. Notice x cannot equal to 0. X cancels out, but x just gives 4x squared plus 20 is equal to 24x. So take away 24x from both sides, gives us 4x squared minus 24x plus 20 equal to 0. And at this point, you want to go ahead and divide everything by 4 to solve this equation. This gives x squared minus 6x plus 5 is equal to 0. So two numbers that multiply to give positive 5 add to give negative 6. So set each of these equal to 0. And we have two answers to this question, 1 and 5. Example, x minus 3 over x equals to 8 over x plus 3. So the LCD is the product of the denominators here, which is x into x plus 3, and x cannot equal to 0 or negative 3. Everything gets multiplied by the LCD, cancel out as necessary, and we're left with x minus 3 times x plus 3 is equal to 8x. Recognize that this is a difference squared, so this x squared minus 9 is equal to 8x. Then take away 8x from both sides. We have x squared minus 8x minus 9 is equal to 0. Factoring x minus 9 x plus 1 is equal to 0. So x minus 9 is equal to 0, so x is equal to 9, and x plus 1 is equal to 0, and take away 1 from both sides, so x is equal to negative 1. So two answers, negative 1 and 9. Now, how do we apply this? Let's consider an example of how to apply this. Lizzie takes 6 hours. Pen's not writing clearly here. 6 hours to paint a room. Mary takes 10 hours to paint the same room. Working together, how long will it take to paint the room? So to solve this problem, we're going to establish a variable, let t equal to the time to paint the room together. And now we want to set up that Lizzie will take 1/6, will paint 1/6 of the room. Mary will paint 1/10 of the room. So the whole room would be in T hours into 1 is the amount of space in the room that will be painted. So we need the LCD of 610 and T. The LCD of 6 and 10 is not 60, it's actually 30, because 30 is the lowest number that you can divide both 6 and 10 into. So 1/6, 30T, plus 1/10, 30T, equals to 1/T, 30T. 6 goes into 35 times, 10 goes into 33 times, and T cancels out with T. So 5T is equal, 5T plus 3T is equal to 30. So 8T is equal to 30. So T is equal to 30/8, which is equal to 15. When you reduce it, 15/4 hours. This is approximately 3.7 hours, in case you wanted to visualize how much time. So FYI, this time has to be less than the time it takes Lizzie to paint the room. That has to make sense, okay? If you're ending up with a number that's greater than 6 or greater than 10, you know that something is wrong, because they're working together, so they're going to take much less time to paint the room. Next, we talk about a very similar problem. John mows a lawn in 60 minutes. Vanessa mows the same lawn in 30 minutes. And if you guys had been in class, I would have been giving you this one to try. How long will it take working together? So remember, the setup here now is John will mow 1/60th of the lawn. Vanessa will mow 1/30th of the lawn. If we establish that T is the time working together, okay? We're going to call that T. I forgot to mention that is equal to 1/T. So 1/60th of the lawn plus 1/30th of the lawn every minute. Sorry, the 1/60th of the lawn and 1/30th of the lawn is equal to the amount of the lawn they will mow in T minutes. So This is LCD now is 60T. So everything gets multiplied by 60T. 60 cancels out. 60, 30 goes into 62 times, and T cancels out with T to give T plus 2T equals to 60. So 3T is equal to 60, so T is equal to 20. Again, notice that your answer makes sense because it has to be less than 30 minutes because they're working together. So if they work together on the salon, it's going to take only 20 minutes to go ahead and do the salon. And now to conclude this section, we're going to talk about something called literal equations. So a literal equation is a formula used to express math relationships. The goal is to isolate the required variable. So I'm going to look at a couple of examples here. I have, first is solve 1 over r minus 2 over s is equal to 2 over t for r. So the goal here is to isolate r. Uppercase r. So on a point of confusion here, the LCD is simply the product of r, s, and t. Because in order for clear r, s, and t from the denominators, we would need to multiply everything by r, s, and t. So we're going to go ahead and set this up. Now we're going to multiply everything by r, s, t. And now we're going to go ahead and see what will cancel out. So r cancels out with r, s cancels out with s, and t cancels out with t. And we have st minus 2rt is equal to 2rs. So the goal here is to isolate the terms that have r first. So I'm going to step out on a limb here and go ahead and add 2rt to both sides. And that allows me to cancel it out from here. So I have st is equal to 2rs plus 2RT. And now I see the opportunity here to go ahead and isolate R by factoring it out. So ST is equal to R into 2S plus 2T. This is an S here. So we finally got R by itself, and all we would need to do now is to divide both sides by 2S plus 2T. 2S plus 2T. This cancels out with this, and we're left with R. We have ST over 2S plus 2T is equal to R. But it's not necessary to do anything else with this equation here. Not necessary to factor out the 2, because that wouldn't do any good. Okay, this is a great answer here. And this is what they want us to do, isolate R. We're able to isolate R in this question. More examples. P over D plus B is equal to G over D. Solve for D. So we need to isolate D here, and to do that, we're first going to clear the denominators. Notice that the LCD is D into D plus B. That's the LCD. That means that every term gets multiplied by that LCD. P over D plus B times D into D plus B is equal to G over D times D into D plus B. D plus B cancels out, D cancels out, and that leaves us with P D equals to G into D plus B. PD distribute on the right hand side, we have GD plus B, so it's GB. Now the goal is to isolate D here, because that's what they're asking us to do. So we need to move that GD term to the left hand side by taking it away. So on the left hand side we have PD minus GD equals to GB. And now we have the opportunity to factor out the D. So you can see all we need to do at this point is divide both sides by P minus G. And we've isolated D on the left-hand side. D is equal to GB over P minus G. All right, that's it for this lesson. I'm going to go ahead and stop this recording.